Welcome to math classes. In this video, we will learn the derivatives. Okay, this is basic introduction to the derivatives and especially for the differentiation. Okay, this is NCERT class 11th, chapter 12. We have already done the from the same chapter. We have done the limits part. Okay, introduction to limits we have done. Now let's do the introduction to derivatives. These limits and the derivatives are very important for class 11th and 12th actually, and who are if you are in intermediate Telangana intermediate syllabus, then this is already there in your board exams. Okay, so very important chapter. It is useful for your physics also. Okay, many problems you will get from these chapters, so understand those basics very well, and after that you can solve many complex problems. That's easy. Okay, if you don't understand basics, then it's a problem. Okay, yeah, next. What we learn in this is limits part we have already covered. So we are covering definition of differentiation, algebra of derivatives or differentiation, some standard derivatives, and then exercise 12.2 and miscellaneous exercise. Okay, these are the things we'll cover. So firstly is yeah, we have seen this slide already actually in the limits video. Let's go through this. Okay, calculus deals with the change in the value of a function as its variable changes. Okay, if you have f of x, how much is the change in f of x with respect to change in x? Okay, so delta f of x divided by delta x. This is what is derivatives are talking about. Okay, so we have two major branches in the derivatives. Okay, our calculus. One is differential calculus. Okay, which will talk about rate of change of quantity, and integral calculus, which will talk about accumulation of quantities or summation. Okay, now in this video basically we will learn the intuitive idea of derivatives. Okay, limits we already learned. Okay, yeah, derivatives measure how a quantity changes with respect to other. Okay, it need not be the variable, it can be with respect to other variable. Okay, any other quantity also. Okay, so this is the most important thing. Okay, and the real life applications includes several things actually. You have a number of things where derivatives are used. Okay, that is reservoir water flow, rocket velocity, stock prices changes. Actually you have so many infinite number of examples where derivatives are used, and nowadays derivatives are just like algebra. Okay, how you learn addition, subtraction, multiplication, and division, you have to learn derivation. Okay, derivatives, and you have to apply it in many places. Okay, okay, let's go to the formal definition. Formal definition is very simple. Okay, we represent it many ways. We can call it a df by dx. Okay, or dh, whatever is the variable. Okay, as well as you can call it f of x is a function, then its derivative is f dash x. Okay, here in this case f dash a. Okay, so f dash a is defined as limit h tends to 0, f of a plus h minus f of a divided by h. Okay, means if you see the numerator is the difference of function with respect to a plus h and a, correct? The function definition at a plus h minus function definition at a divided by h. And what is h? H is very small value of uh, very close to 0 basically. Okay, very small value. Okay, so this is the basic definition. How much is the rate of change of the function with respect to h? This is what the derivative or differentiation definition. This is also called first principle of derivative or differentiation. Okay, now from the graph, if you see the graph here, okay, if you see the graph here, I am calling this a secant line. Okay, why it is secant line? It looks like a tangent, right? Okay, this is the end. Okay, let's say you have a curve like this, and you cut the curve with a line at two places. Okay, at two nodes or whatever, two places. Then you slowly reduce that distance between those two spots. Okay, those two places. Okay, if it is AB, okay, and start reducing AB, then the secant slowly will become will be touching the curve at one point. That is nothing but tangent, correct? So the secant line will become tangent when you apply the limit definition, correct? H tends to 0. Okay, now you know that the height of, if it is, let's say it is touching at two places, the length between those two is nothing but the if you take the y coordinates, right, if you take the y coordinates, difference between the y coordinates, that is nothing but f of a plus h and f of a. Okay, and the difference between those two x coordinates is h, so which is here. So this is a very simple tangent line to any given curve. Okay, is nothing but derivatives. Okay, so important thing is it's a slope, it's a tangent. Okay, so all these things you should remember because we may have to sometimes apply these basic principles. Okay, yeah. Let's see some derivatives of some few functions. Okay, I will show you how to derive these derivatives using the first principle in the forthcoming slides, as well as we have exercises where we will be doing that. Okay, so this is just to give a understanding of what are the derivatives. Okay, so if you take f of x as 3x, then f dash x, that is the first derivative of f of x. Okay, differentiation is 3. Okay, the variable term is not there, means. Okay, how to understand this one? So f of x changes at a rate of 3 when there is a change in x. Okay, that is what we should understand. And it is a constant rate. No change. There is no change. If you take f of x equal to 2x square plus 3x minus 5, then f dash x is 4x plus 3. Now here, the rate of change is not constant. It is variable. Okay, it is changing with the value of x. It depends on x also. Okay, that is what you should understand. Now if you relate these two, okay, f of x equal to 3x, then f dash is 3, right? So if you take, see here, there is a 3x term here and there is a 3. Okay, which means differentiation of 3x equal to 3 is here, and differentiation of 2x square is 4x, looks like, and for minus 5 there is nothing. Okay, so for constant terms there is no differentiation is 0. Why? It's very simple, right? There is no change in the constant term. Constant term will never change. So there is no question of rate of change there. So differentiation of constant term is 0. So this is 0. This is 3. This is 4x. How it comes, we will see. Okay. So, and also you can also derive one thing. You can actually sum up the differentiation by doing differentiation of each term and then add them. Correct? I am doing differentiation of this term, this term, this term, and adding them independently. Okay. So you can understand that, right? And there is also differentiation for any kind of function. So trigonometry is one function. Okay, if you take f of x as sin x, f dash x is cos x. Okay, we will see how it comes. That's we'll see those. Okay, and we are already understood constant functions have zero derivative because there is no rate of change in constant functions. Okay, so these are some basic examples. Okay, and some algebra rules of derivatives. One is sum rule, we understood in the previous slide. Okay, if f and g are two different functions, then f plus g differentiation, that is dash, is nothing but f dash plus g dash. You can apply differentiation to the individual terms. Okay, now difference rule also same, just addition and subtraction exactly same. Okay, this is f dash. Okay, sorry, this is f dash. Okay, the product rule is this is called Leibniz rule. Okay, f into g derivative differentiation is equal to f dash g plus f g dash. Okay, I think this looks easy, right? You first differentiate the first term, then multiply with the second term as is, plus keep the first term as is and multiply with differentiation of the second term. That's it. Then quotient rule, f by g dash is nothing but f dash g minus f g dash divided by g square. Okay, so if you see this one, product rule and this one, it is almost same except there is a negative. Okay, instead of plus you have a minus term, and then uh, uh, divide with the g square. Okay, okay, this is provided g is not 0. Okay, g of x is not equal to 0. Okay, so these are the algebra of derivatives, which are very simple. Okay, only thing is functions may go very complex, so doing differentiation sometimes becomes very difficult. Okay, you should have some patience to do that. Okay, some standard derivatives we'll see how we got it. Okay, one is if f of x equal to x power n, then differentiation we can write it in this form also, right? Dx to the power of n divided by dx. Okay, dx power n by dx equal to n times x to the power of n minus 1, means the power comes to the product and power reduces by 1. Okay, this is very important definition of derivative. Okay, so you have to remember there should be, I mean, there by end of this chapter and end of class 11th you will have a big list of differentiations which you should remember, and best way of remembering is do some problems based on those. Okay, then you will remember very easily. Okay, let's derive it from the first principle. First principle says limit h tends to 0, f of x plus h minus f of x divided by h. Correct? So f of x plus h is nothing but x plus h whole to the power of n, because f of x is x to the power of n minus x to the power of n divided by h. Now if I expand this one, what I will get is, okay, if I expand this one, I get a x to the power of n term, x to the power of minus n is there, minus x to the power of n is there, so both gets cancelled. So I am left with other terms, which are the other terms? N times x to the power of n minus 1 h plus nc2 x to the power of n minus 2 h square plus up to h to the power of n. Correct? Everywhere you have at least one h. So if you are dividing with h, you will be left with n times x to the power of n minus 1 plus some function with h. Okay, each term in this O of x, order of h, is there is one h. Okay, so this, if I apply the limit h tends to 0, this O of h will become 0. Correct? I am left with only n times x to the power of n minus 1. That is what differentiation of x to the power of n. Okay, so you understood how to do differentiation from first principle. Okay, this is one example. Let's see for sin x. Okay, we just told trigonometric functions also have differentiation. Okay, so f of x equal to sin x. Okay, derivation is cos x. Let's see how we will get cos x here. This is the standard definition of derivation. Okay, now what is f of x plus h? Nothing but sin of x plus h minus sin x divided by h. Now I will expand the sin of x plus h using sin of a plus b, which is nothing but sin x cos h plus cos x sin h minus sin x divided by h. Now we know that limit is h tends to 0. Correct? Limit is h tends to 0. Okay, then cos h will become 1. Cos h is 1. So this will become sin x minus sin x divided by h plus cos x into sin h by h. Okay, so two terms I made it. This part we know it is 0, and this part sin h by h, limit h tends to 0, sin h by h is 1, so this will become cos x. So the differentiation of sin x is cos x. Okay, so this is how you basically derive the differentiation of each one from the standard first principle, basically standard derivations from the first principle. Okay, so let's see some more just standard derivatives, and then we'll get into exercise where we will be doing more practice of these things. Okay, one we know, first one we know already, dx by x to the power of n actually. Okay, this is x to the power of n is nothing but n into x to the power of n minus 1 for any positive integer n, and the derivatives of polynomial functions follows term-wise differentiation. Okay, means I can differentiate each term in the polynomial. Trigonometric differentiations are here. One is d of dx of sin x equal to cos x, and differentiation of cos x is minus sin x. Okay, remember there is a minus sign. Differentiation of tan x is secant square x. Okay, differentiation of cot x is minus cosecant square x. Okay, so remember, and there are many more actually. You have to remember a big list of things. Okay, so be prepared for that. Okay, and now let's get into the exercise and miscellaneous exercise from the NCERT chapter, class 11th exercise. I mean, chapter 12. Okay, this is 12.2. Find the derivative of x square minus 2 at x equal to 10. Okay, this is a very simple problem. We directly can solve it because it is in the form of x to the power of n. Correct? So differentiation of x to the power of 2 is nothing but 2x. Okay, and at x equal to 10, that's value is 20. 2 into 10, which is 20. Okay, and if you want to solve it using first principle of derivation, then this is how you will do. Limit h tends to 0, f of x plus h minus f of x divided by h, which is nothing but x plus h whole square minus 2 minus of x square minus 2 divided by h. Simplify it all, you will get 2x actually, again same thing. And at x equal to 10, df by dx equal to 20. That's the answer. Okay, so all other problems also you should do. Only thing is, keep as you are doing for the first time, you please observe what is happening. Okay, so let's say a derivation of x, very simple, right? Okay, which is nothing but 1, we know it, and at x equal to 1 it is 1. Correct? Df by dx is equal to 1 because it is independent. X equal to 10 also it is 1, x equal to 100 also it is 1. So what is the meaning of it? The meaning is the rate of change of f of x is constant. Okay, it is not changing with respect to x, but it is changing constantly, but it is not changing with respect to x. It is not dependent on x. That's all. Okay, so similarly for derivative of 99x, okay, at x equal to 100, So derivation of 99x is nothing but 99. So at x equal to 100 or 1000 or 1 or 2, whatever value you take, it is still df by dx equal to 99. Okay. Next. Find the derivative of the following functions from the first principle. Here, this case we have to use first principle just to understand how to use this. Okay. So do it carefully. X cube minus 27. Okay, let f of x equal to x cube minus 27. Then by definition, it is limit h tends to 0. F of x plus h minus f of x divided by h. Right. This is the definition of derivation by first principle. Now, what is f of x plus h? Is nothing but x plus h whole cube minus 27 minus f of x. So minus x cube minus 27. Write the terms carefully. Divided by h. Now we expand it and remove the terms which can be cancelled, like x cube can be cancelled here. Okay, then you are left with h cube. Correct? You are left with h cube plus 3x square h plus 3x h square. Okay, 3x h square. So these are the terms you are left with, and divided by h. Okay. So if you divide this with h, I think this should be h square actually. Okay, because already division is already done. So this is h square plus 3x square plus 3xh. Okay, and at h equal to 0, this term and this term will be 0. So we are left with 3x square. So now we know from the x to the power of n also, we know that it is same, right? If you substitute x to the power of n, n into x to the power of n minus 1, which is 3 into x to the power of 2, and this is constant, so it will be 0. So you cross check your derivation directly also. Okay, so this is the way to solve using first principle. You can solve other problems also. X minus 2 into x minus 1 into x minus 2. So again, same thing. You take f of x equal to x minus 1 into x minus 2. If you are confused how to take this in the limit, then you just multiply and take it as a simple polynomial. X square minus 3x plus 2. This is nothing but. Then you substitute f of x plus h is nothing but x plus h whole square minus 3 times x plus h plus 2 minus f of x is x square minus 3x plus 2 divided by h. If you simplify, this is what you will get. Okay, so limit h tends to 0. 2x plus h minus 3, h is 0, so it is nothing but 2x minus 3. Okay, so this is the derivation of x minus 1 into x minus 2. Okay, next 1 by x square. Again, same way you will do. Only thing, just be careful. F of x plus h minus f of x divided by h. F of x plus h is nothing but 1 by x plus h whole square minus 1 by x square by h. You take LCM, okay, and LCM is here into h, and then these are the terms you will get there. So you cancel the terms and then multiply this product here. Okay. Finally, if you simplify and substitute h equal to 0, you are left with minus 2x by x to the power of 4, which is nothing but minus 2 by x cube. Okay. So derivation of 1 by x square with respect to dx is nothing but minus 2 by x cube. Okay, this is the answer. Now if you see here, this is nothing but x to the power of minus 2. Okay, x to the power of minus 2, if it is in the form of x to the power of n, then it is minus 2 into x to the power of minus 2 minus 1, correct? Which is nothing but minus 2 into x to the power of minus 3. X to the power of minus 3, I can write it as 1 by x cube. So this is the answer. Okay, next. X plus 1 divided by x minus 1. Everything you will do exactly same way. Okay, only thing is you should do very, very carefully. Okay, this is nothing but f of x plus h is nothing but x plus h plus 1 divided by x plus h minus 1 minus x plus 1 divided by x minus 1. Okay, now you take the LCM, and the LCM is here into h because h is already there. Okay, these are the terms. So multiply the terms here and simplify them. What you will get is minus 2h divided by h into x plus h minus 1 into x minus 1. Now you substitute h equal to 0. Or first thing is you can cancel h and h here. Okay, so this is the remaining term. Now you substitute h equal to 0. What you will get is minus 2 by, okay, this is 0, x minus 1 whole square. Correct? So minus 2 by x minus 1 whole square. For the function f of x equal to x to the power of 100 divided by 100 plus x to the power of 99 divided by 99 plus up to plus x plus 1, prove that f dash 1 equal to 100 times f dash 0. Yeah, for this we just need to find out first of all f dash x. Okay, then substitute values 1 and 0 and see what's the values. So f dash x is nothing but this is in the form of x to the power of n. Each term is in the form of x to the power of n.
So differentiation is n into x to the power of n minus 1, correct? So f dash x is equal to 100 into x to the power of 99 divided by 100 plus 99 into x to the power of 98 divided by 99 plus up to 2x by 2 plus 1. Okay, if I substitute f of 1, okay, if I substitute f of 1, this is nothing but each x is replaced with 1, so I am left with 1 plus 1 plus 1 plus 100 times, that is 100. And f dash 0 is nothing but all these terms get zeros and only 1 is left, that is f of 0, f dash 0 equal to 1. Okay, so now this, from this we can easily say that f dash 1 is equal to 100 times f dash 0. So hence proved. Okay, next. Find the derivative of x to the power of n plus a into x to the power of n minus 1 plus a square into x to the power of n minus 2 up to a to the power of n. Okay, for some fixed real number a. This is also similar to the above one. Okay, each term we have to differentiate, and each term is in the form of x to the power of n. Okay, so f dash x is nothing but n into x to the power of n minus 1, n minus 1 into a into x to the power of n minus 2, and so on. Okay, last. Okay, this term is 0, but you will get this term a to the power of n minus 1, because this is a to the power of n minus 1 x. Okay, so these are the terms. Now I can just simplify them. Okay, I can see that I mean, if I substitute a, I can see that each term has a to the power of n minus 1, correct? A to the power of n minus 1 is there in each term. So I take a to the power of n minus 1 common. Okay, a to the power of n minus 1 I am taking common, then I am left with n plus n minus 1 plus n minus 2 up to 1. Okay, so which is nothing but sum of n integers from 1 to n, which is n into n plus 1 by 2. So n into n plus 1 by 2 multiplied by a to the power of n minus 1. This is the required value. Okay, next. Find the derivative of x minus a into x minus b. Okay, this you can do using the derivation of f of x into g of x, which is equal to f dash x gx plus fx into g dash x. You take first term, okay, derivation of first term multiplied by second term as is, plus first term as is and multiplied with the derivation of second term. Okay, example here is, okay, for derivation of x minus a into x minus b is nothing but x minus a derivation is 1, so 1 into x minus b plus derivation of x minus b is 1, so 1 into x minus a. Okay, which is nothing but 2x minus a minus b. This is the derivation. Okay, so you are applying this product derivation product formula. Okay, ax square plus b whole square. This one we use the chain rule. Okay, what is the chain rule? I'll explain here. Okay, we know that derivation of x to the power of n is nothing but n into x to the power of n minus 1. Okay, and then we use the chain rule. Chain rule is, you consider this whole term as f of x. Okay, this whole term is f of x. This is f of x whole square. So first treat it as if it is x square. Okay, okay, when I am deriving, I treat this as if this is x square. So x square derivation is 2 into x to the power of 1, correct? So 2 into x square plus b. Now I apply, multiply derivation of this inner one, f of x, which is nothing but 2ax. Okay, okay, I can keep on going on until I get, actually until I do until I get 1. Okay, so this is the last, right? So 2 into ax square plus b into 2ax, which is nothing but 4ax into ax square plus b. Okay, until x term is there, I will do. Okay, so this is the one. This is the chain rule, which is very important. You should understand and do more problems based on this chain rule. Okay, and once you go, I mean, high level derivations, so this is one of the very common thing to use. Okay, next. X minus a by x minus b. Derivation of this one is, it is in the form of f of x by g of x. So the formula is here, f dash x into g of x minus f of x into g dash x divided by g of x whole square. Okay, so do carefully. This is my f of x, this is my g of x. Okay, if you do carefully, you get the answer. Next. This is also similar. This is also in the form of f of x by g of x. Okay, so similarly, you do this one also. Okay, do it carefully. Okay, 2x minus 3 by 4, which is a straightforward derivation of this one, correct? Which is nothing but 2, because minus 3 by 4 derivation is 0. Then 5x cube plus 3x minus 1 into x minus 1. You can do it two ways. Either you multiply it and make one single polynomial and then solve it, or you apply the f of x into g of x derivation rule. Okay, UB we call it. UB derivation is UB dash plus BU dash. Correct. So you can do whatever way. I've just tried the second way. Okay, and this is what you will get. Next, x to the power of minus 3 into 5 plus 3x. Okay, this is also you can do it in UB, that is f of x into g of x derivation, or if you want to write it as 5 plus 3x divided by x cube, you can apply f of x by g of x derivation rule also. Okay, in both ways you will get the same answer anyway. Okay, so yeah, do it term by term, you will get it. Next, x to the power of 5 into 3 minus 6 x to the power of minus 9, again same way you will do it in f of x into g of x derivation. Okay, you will apply, and this is the answer. Okay, x to the power of minus 4 into 3 minus 4 times x to the power of minus 5. Okay, so here also you apply, this is g of x, this is f of x, this is g of x. Okay, then you apply f of x into g of x. Okay, which is easy actually. Okay, so yeah, next is 2 by x plus 1 minus x square by 3x minus 1. You can apply f of x by g of x for each term. Okay, so first term is here, second term is here. Okay, let's do it. First term is differentiation of 2, which is 0, so 0 minus. Second one is 2 into differentiation of x plus 1, which is 1, so minus 2 divided by x plus 1 whole square. So this is my first term differentiation, minus second term x square into differentiation of denominator is 3 minus, okay, minus differentiation of x square is 2x into 3x minus 1. You simplify this, this is what you will get. This is the overall differentiation. Okay, next, find the derivative of cos x from the first principle. Okay, we have done it for sin x, it is exactly same. You can do it again. First principle is limit h tends to 0 f of x plus h minus f of x divided by h, where f of x is cos x. So this will become cos of x plus h minus cos x divided by h. Cos x plus h, I will expand it using cos a plus b, okay, which is nothing but cos x cos h minus sin x sin h minus cos x divided by h. Okay, so cos h, if I substitute 0, it will become 1. Okay, so I am left with cos x minus cos x divided by h, minus sin x sin h divided by h. Okay, so this is nothing but I am finally left with sin h by h into minus sin x. So this is 1. We know that limit h tends to 0, sin h by h is 1. So this is nothing but minus sin x. Okay, so derivation of cos x is minus sin x. Next, sin x cos x, you will apply differentiation of ub, which is u dash v plus u v dash. Okay, so just apply it carefully, you will get cos 2x as the answer. Secant x, yeah, derivative of secant x, we will apply the rule of differentiation of u by v form. Okay, u dash v minus u v dash divided by v square, and we will take f of x as 1 by cos x. Okay, so we already know what is for cos x, so it is very easy to do with cos x, right? So 1 by cos x I will take as secant x. So the answer is tan x into secant x, and these are the values you should remember for your differentiation, either maths or physics. Okay, so you need to remember this. These are very standard formula for differentiation. Okay, next, 5 secant x plus 4 cos x differentiation. Again, I will apply similarly for the first term. I will apply u by v form, or I should remember this. Okay, differentiation of secant x is nothing but tan x into secant x. We derived here, right? Okay, then it is nothing but 5 into tan x into secant x minus, okay, plus cos x is minus sin x. So 4 into minus sin x, that is minus 4 sin x. So this is what you will get finally. Okay, so you should solve it once directly using formula, and then you have to remember individually. Okay, you don't need to remember these things, but you have to remember differentiation of secant x, of cos x, of sin x, of tan x, and everything basically. Okay, those basics. Okay, cosecant x, this is also you should remember. You can do it using differentiation of u by v. You will get minus cot x cosecant x. Okay, see the difference here. Secant x, we got positive tan x into secant x. Cosecant x, you got minus cot x into cosecant x. Okay, minus sign is there. Okay, be careful. So cos you have minus sign, cosecant you have minus sign. Okay, next. Yeah, 3 cot x plus 5 cosecant x. Yeah, we can again use the differentiation of u by v form for both of them. Cot x, I will write it as cos x by sin x, and cosecant, if you remember, you can straightforward write it here like minus phi cot x cosecant x, or you do it by phi by sin x and then do it. Okay, so you will get the required answer. Phi sin x minus 6 cos x plus 7. So differentiation is straightforward. 5 into sin x differentiation is cos x, correct? So 5 cos x minus 6 into cos x differentiation is minus sin x. So minus 6 into minus sin x, which is plus 6 sin x. And constant term differentiation is 0. So this is the answer. Okay, this is how you should write straightforward. Okay, by remembering the standard differentiations and then directly doing. This is how you should write. Okay. Yeah, 2 tan x minus 7 secant x. This is the detailed way of explanation, but let's do it directly. 2 tan x is nothing but 2 tan x differentiation is secant square x, right? So 2 secant square x minus 7 secant x. Secant x differentiation is tan x into secant x. So minus 7 tan x into secant x. This is the answer. Okay. You do detailed also, you'll get same basically. Okay. So for multiple choice and objective type of questions, you have to remember and do it. For theory questions, you have to solve it this way. Okay. Next. Yeah, let's do some miscellaneous exercise now. Okay, so these are the problems in NCERT book. They look very simple, fundamental questions, but this is the first time you are introduced to differentiation, so they look very fundamental. There are very complex problems actually based on these same concepts. Okay, concepts are very simple. This is the only way you will solve it. And I mean, you do the differentiation. So keep doing more such fundamental problems here in NCERT book. Then later you can do a very complex problem for your JEE. Okay, that anyway I will make my videos and shorts. Okay, so let's do miscellaneous exercise now.
Find the derivative of the following functions from the first principle. Okay, so this you have to apply the first principle. Okay, minus x. Okay, this is very basic. You can do it yourself. And what we should follow, we have to use this first principle of the derivation, which is limit h tends to 0, f of x plus h minus f of x divided by h. Okay, you substitute the values properly, you will get the answer. Okay, this is very fundamental question. Okay, minus 1 is the answer. Okay, and minus x whole to the power of minus 1, this is nothing but 1 by minus x, correct? So you can apply again first principle, which is limit h tends to 0, f of x plus h minus f of x divided by h. Okay, you will get 1 by x square. Okay, if you do it directly, you will understand. Minus 1 will come here first. Okay, so minus 1 into minus x to the power of minus x to the power of minus 1 minus 1, which is minus 2, correct? So minus x to the power of minus 2, which is nothing but minus gets cancelled in the front, so it will become 1 by x square. Okay, next. I think all are very fundamental questions. Okay, you can do it yourself. Some of them we have already solved. Sin x plus 1. Okay, if you directly differentiate, you will get it cos x plus 1. Okay, which is the answer here, and you just follow the fundamental this one first principle. Okay, so you will get same. Only thing is, make sure that x plus 1 you treat it as one angle. Okay, x plus 1 as y. Okay, then so it will become y plus h minus whatever. Okay, f of y plus h plus minus f of y, like that. Okay, so treat this as one number, one term. Okay, yeah, cos of x minus pi by 8, you will again get minus, this is nothing but minus sine x minus pi by 8. Okay, so you will get that answer. Even the angle is not x, if you differentiate this one, you will get 1 again. It will, if you differentiate, you will get 1 and you will stop it there, right? So that's the last. Okay, next. And this is a direct derivation, so you can do it yourself. Very basic questions. Okay, answers are here, you can cross check. X plus a, directly you will differentiate. Okay, this is 1, this is 0. Okay, basically this is the variable, this is constant, so for constant it is 0. 1 plus 0, which is 1. Px plus q into r by x plus s, you will follow differentiation of uv, which is nothing but uv dash plus u dash v. Okay, so you can do it directly. Okay, this is the given function, so px plus q into minus r by x square plus p times r by x plus s. Okay, you simplify, you get this, so minus qr by x square plus ps. Other terms gets cancelled. Okay, so you simplify it. Ax plus b into cx plus d whole square. Okay, so again you will follow same uv rule. Okay, and you will get the answer. This is the answer here. Okay, ax plus b by cx plus d, you will follow u by v, differentiation of u by v, which is u dash v minus u v dash divided by v square. Okay, so you will get AD minus CB divided by CX plus D whole square. Okay, 1 plus 1 by x divided by 1 minus 1 by x. If you simplify, it is nothing but x plus 1 divided by x minus 1. So you apply differentiation of u by v, and then you get the answer. 1 by x square plus bx plus c. You apply again differentiation of u by v rule. You will get the answer. Okay, do it yourself and just check here. You can, if you go wrong, you check it here. Okay. These are all very fundamental and basic derivations. This is a kind of a practice for you how to do this uh, from the basic principles algebra, derivation of algebra of derivation. Okay. Okay. So this is similar. You will apply again u by v, derivation of u by v rule. Okay. Same, exactly reverse of this one. Same. You will apply same similarly. Okay. A by x to the power of 4 minus b by x square plus cos x, which is f of x. Okay. Now I can directly do it. Easy way is, if instead of keeping it in the denominator, because there is only one variable, okay, you call it, sorry, this is not minus, just a x to the power of minus 4 minus b x to the power of minus 2 plus cos x. Okay. There is no minus, so minus sign you just ignore. Okay. So only in the end you will get minus sign. Okay. So for this one, it is minus 4a into x to the power of minus 5. Minus 4a into x to the power of minus 5, which is x to the power of minus 5 in the denominator. Okay, for this one, it is minus 2 into minus, which is 2, 2b x to the power of minus 3. So plus 2b by x to the power of 3. For cos x, it is minus sin x. Okay, so this is how you do it. Okay, this is also straightforward. You can do it yourself. You write it as x to the power of half. Okay, so when you do differentiation of x to the power of n, we say that it is n into x to the power of n minus 1. So n need not be integer. N can be fractional. Okay, rational number. Any rational number. N is any rational number. So this is nothing but half into, okay, 4 is already there. X to the power of half minus 1. Okay, so this will become, so if I simplify it to 2 by square root of x. Okay, next. Yeah, this is very simple chain rule you will apply. This you will assume that x to the power of n. So n into x to the power of n minus 1, and then inside one you will differentiate again. Once again you get a. Okay, chain rule. Similarly, you will apply both the chain rule as well as the differentiation of UV rule. Okay, you simplify it, you will get this answer. Okay, sin x plus a, which is very simple, straightforward, which is cos x plus a. Cosecant x into cot x. Okay, you will apply differentiation of UV rule. Okay, so this is the answer. Okay, again you will apply differentiation of u by v for this 16th question. Okay, yeah, sin x plus cos x by divided by sin x minus cos x. Okay, you will apply differentiation of u by v, which is straightforward. Only thing is, assume that this is one term is here. This sin x plus cos x is one term, sin x minus cos x is the other term. Okay, so you will get minus 2 by sin x minus cos x whole square. Okay, secant x, either if you want, you can make it as 1 by cos x and do it, because that is, cos differentiation is more simpler than secant x. Okay, if you want, you can do that way. Sin to the power of n x. Okay, this is chain rule we will apply. It is nothing but n into sin of n minus 1 x into sin x differentiation is cos x. Okay. Similarly, you will do like u by v. Okay, same as before. Okay, here it is same actually. You will apply differentiation of uv rule. Only thing is, x power 4 is one term and 5 sin x minus 3 cos x is your other term. You can do it directly, because in 5 sin x minus 3 cos x, you can individually differentiate the terms. Easily you will get value. Okay, so let's do this. First is u dash v. So u dash is 4x cube into 5 sin x minus 3 cos x plus x to the power of 4 into 5 cos x plus 3 sin x. 5 cos x plus 3 sin x. Now you simplify it, you will get the answer. That's it. Yeah, same way you can apply differentiation of uv. Again, same differentiation of uv you can apply, because their terms are simple. Individual terms are simple. You can differentiate easily. Same. Okay. Yeah, 4x plus 5 sin x divided by 3x plus 7 cos x. You will apply the differentiation of u by v rule. Okay. Do it. Each term is a simple term, not very complex. You can do it. x square cos pi by 4 divided by sin x. Okay, so this is also, if you see it, cos pi by 4 is nothing but 1 by root 2. So you substitute the value 1 by root 2 and then do it. It is very easy. Okay, otherwise you will get confused and you will do differentiation of cos pi by 4 as sin pi by 4 minus sin pi by 4. Okay, this is a constant term. Okay, this is the answer you will get. So these problems, why these problems are important if we are just skipping like this, these are the problems you will get in your boards or JEE, and this is the only way you will solve. Either you will apply, basically you apply the algebra of derivations, right? Either you apply differentiation of u v rule, differentiation of u by v rule, or chain rule. These are the three main techniques which you will use, right? These are not three main, these are the techniques. That's it. Other things you should know. What is the differentiation of log x? What is the differentiation of e to the power of x? These things you should know. Okay. For your information, differentiation of log x is 1 by x. Differentiation of e to the power of x is e to the power of x only. Okay. Yeah. Same way you will do it. Okay. So yeah, these are all not very complex. You can do it yourself. Yeah. Yeah, these are the problems actually. Very basic and fundamental problems from NCERT book actually. There will be more and more complex problems on differentiation as well as limits. So those I'm making the YouTube shorts actually, and and the videos. Okay, critical problems, especially JEE and BITSAT PYQs, they are all, and some practice questions also there. Similarly, now I will start adding practice questions and JEE PYQs for derivations also. Okay, there you will see the complexity and how to apply these rules there. Okay, these are the fundamentals, this you should know. And problems level of problems will increase when you go to engineering entrance exams. Okay, yeah, thank you.